Okay, when it comes to 3D word problems, you have all the tools and techniques you need. It's just a matter of interpreting the question. So it's really hard in 3D problems to see what's happening. So on the test, we will help you out and give you a partial sketch, but you have to fill in the rest, okay? So it'll help you a lot, but you're just we might give you a diagram like this, and we'll help you out. And you know that this symbol means 90 degrees, right? Right? Those squares mean 90 degrees. So let's look at this. This question actually gives you a lot of information you don't need, so we have to kind of shift through that information. Okay. So a Coast Guard helicopter is 226 meters above the ground. So that's filled in for you, right? You could call that height or whatever you want to call that. Hovers between two sailboats. From sailboat A, the angle of elevation is 60 degrees. Just so you know, let's just review out. Let's say this is an eyeball right there. If there's the horizontal, right? So the angle of elevation, let's say I'm looking at a hot air balloon or something in the sky, okay? The angle of elevation is the angle between the horizontal and the line of sight to the balloon. So this is angle of elevation. Now, let's say this is an eyeball looking down at a mouse. Little guy with whiskers and everything, right? Now this is the angle of depression, right? It's between the horizontal, we'll call that horizontal, that's the horizontal line, and the line of sight to the mouse. So this is angle of depression. Okay. So in this question, they are giving you the angle of elevation. They're saying from sailboat A, the angle of elevation is 60 degrees. From sailboat B, the angle of elevation to the helicopter is 30 degrees. Now this is where it's really hard to understand. So from the helicopter, the angle between the lines of sight. So let's say my helicopter is up here. Can you see this? I don't know if you can see this. And then you have, we'll call this, it's kind of hard. This is sailboat A, say. This is sailboat B. Sailboat A, sailboat B. Let me move this up a little closer. So, when they say the lines of sight, they're referring to this, then to this. They're talking about that angle that's sort of in the air between this line and this line. They're saying that angle between the line of sight to the sailboats are 49.5. From the ground, now this angle from the ground, they're saying the angle between the boats is 60 degrees, right? And then they're mentioning this one. The angle between this and this is 19.1, but we don't need it. So we don't need all that information to find the answer. All we need is this guy, this guy, this guy, and this guy. We don't need the other guys, actually. So let's do it. Let's do it. Let's call this side I'm going to see that the base where it touches the ground, you know, where from directly below the helicopter, right on the ground. Why don't we call that vertice? We'll call it G for ground. How's that? Okay, so opposite this guy, we'll call it A right here. And opposite angle B, we'll call that little b. Hard to see, right, because the diagram isn't the best. So can you see that? Well, we have this angle. If we had this side and this side, we could find the distance between the two sailboats. Why don't we just call it, we could call it little g. Let g be the distance between the two sailboats. Okay, any ideas? The only measurement of a side we have is the height. We have height, we need that. That's kind of like opposite and adjacent, right? So we'll use 10. This is a right angle triangle, this is a right angle triangle. So tan 30 degrees is equal to 226 over A. So A equals 226 over tan 30 degrees. And I calculated it for you. 391.4434 approximately. They wanted to all your test questions, you're going to round to the nearest tenth. We're going to keep it simple on the test, okay? Everything, angles, lengths, everything on the entire test is to 1/10. Except when you don't have a calculator, then you just do it accurate. Okay, now B, tan of 60 degrees is equal to 226 over B. So B equals 226 over tan of 60 degrees. So B is approximately equal to 130.4812. Sorry? Oh, it's the length, my bad. Thank you so much. So this would be approximately in meters, right? My bad, my bad. Yes, thank you for pointing that out. So now we have side angle side. What law do we use for side angle side? Cosine law, right? Remember, for cosine law, you use, if you see side, 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 you're using cosine law, and if it's side angle side, you're using cosine law, okay? The contained angle. So now we have G squared equals 391.4434 squared plus 130.4812 squared minus 2 times 391.4434 times 130.4812 times the cos of 60 degrees. And if G squared is approximately equal to 119,177.333. G is approximately, take the square root of that, 345.2. So the distance between these sailboats is about 345.2 meters. This is approximately an 8-mark question. Approximately. You know, 1 mark for completing the diagram. You're setting this up. You're setting this up. You're writing a conclusion, right? Well, well, yeah, on the test, actually, you're given a lot of information you don't need. On the test, you're just going to be given information you need, so you probably won't have that angle. All right, so then, yes, I agree with you. It's a little easier. Okay, I just want to make sure you get the practice with cosine law. Can I answer any questions? Excuse me, rise and shine. You got all this? Okay, good. Makes sense? Okay, good. Are we good? Can I flip? Move it up? Want it higher? No? You like this? Yeah, it's just getting it's the diagram that's very difficult. Okay, ready? While Travis and Bob were flying a hot air balloon from Beansville to Vineland, they decided to calculate the straight line distance to the nearest meter between the two towns. Okay, this one, guys, this one is similar to this one, but notice in this one we focused on this triangle, right? This one is different. We're going to focus on this triangle. So this one here. So watch. This is where it can get confusing. Okay, so they say from an altitude of 226, right? So this is a hot air balloon of some. Oh, I don't know why I'm flipping into degree. Must be my old age. Okay, from Beamsville, here's Beamsville, and here's Vineland, say. Here's their balloon. They say the angle of depression. Ooh. Okay, so the angle of depression between the horizontal, this is a 3D problem. It's going to look more like this. But they're telling you the angle of depression to Beamsville is 2 degrees. So what's the angle of elevation to the balloon? Do you see parallel line theorem Z pattern? So just because it says depression, this is 2 degrees, right?
So what's the 2 degrees at the top?
Well, that's the angle of depression. But because of parallel line theorem Z pattern, you know that's 2 degrees. And similarly here, the angle of depression is 3 degrees, but you know because of parallel line theorem Z pattern, this is 3 degrees. Right? The angle, well actually, it's here. The 3 degrees is here, not there. Because it's hard to see because of it's a 3D issue. So Parallel line theorem, 3 degrees. Parallel line theorem, 2 degrees. Now they want us to calculate this. We'll call that, well, why don't we call this guy capital H for hot air? Because we have a B for, we'll call that H. So the thing in this triangle, yes. Yeah, because this is, when they measure height, they measure the perpendicular distance. We don't know anything here. It's a big fat question mark. They measured the angle between the two lines of sight. So we have this angle here between the two lines of sight. This angle here. Can you see that this angle is not the same as this angle? That is 80 degrees. So we're dealing with this triangle. We're not dealing with this one. We're dealing with this guy. It's the angle between the lines of sight is 80 degrees. We don't know this angle. We can't work with this triangle. We have no angle measurements down here. So we're going to work with this sort of surface triangle. In order to help you picture it, I don't know if this helps. We are now dealing with this triangle here. Right? We're dealing with this triangle. Not this, we're not dealing with this triangle. We're dealing with this one. It's different. So we'll call this B, we'll call this V. Any ideas how we can do this? Huh? Okay, let's do our let statement. Let the distance, or you could just say, let the variables be as shown on the diagram. That would be easiest. Can we find B? So sine of 3 degrees equals what? 226 over B. Okay, are we okay with this diagram? Kind of. So B equals 226 over sine of 3 degrees. Sine of 2 degrees is equal to 226 over opposite over hypotenuse over V. V equals 226 over sine of 2 degrees. Now we can find our H. We have side, angle, side, right? Side, angle, side, that's for the cosine law. So H squared equals 226 over sine of 2 degrees squared minus 2 and it's cos of 80 degrees. Oh, like this? More accuracy. If you want to solve this to 4 decimal places and work with that, you're more than welcome to. So 8 squared is about 7132, no, h, take the square root of that, 7132.4 meters. Your conclusion is worth 1 mark. The distance between the two towns is 7132.4 meters.
Is that 752 or
Yeah, it's 50870,752.92.
Can we say like this approximately?
Sorry?
Should we say like the distance between the two towns is this? Should we say the distance between the two towns is this, or should we say the distance between the two towns is
You can
approximately?
say about or approximately. It's better if you say approximately. Want to do one more example or try it on your own?
Can we try grabbing the diagram?
You want the diagram? Okay. You want the diagram. Okay, we'll give you the diagram. Okay, two roads intersect at 34 degrees. Two cars leave the intersection on different roads of speeds at 80 kilometers per hour and 100 kilometers per hour. So the guy at 80, after 2 hours, he goes 160 km. The other guy at 100 kilometers per hour, after 2 hours, he goes 200 km. The helicopter that is above and between, okay, the angle of depression to the slower car is 20 degrees, so that makes this 20. Well, that's this, oh, yeah, that's the slower car. He only went 160. The angle of depreciation, oh, we don't know that. I guess that's all we've got. The straight line distance from the helicopter to that car is 100 km. We'll call this slow car, fast car, helicopter. This is at right. This is right in between.
You have to multiply 160 by 2
Yeah, so 80 times 2 is 160.
Oh,
And 100 times 2 is 200.
I didn't read the question. We saw what
Calculate the straight line distance from the helicopter to the faster car. We'll call that x. Determine the altitude. We'll call that a right there. Okay, how's that? Let variables be as shown as in the diagram. So I don't know if this should be 100, right? Can you take it from there? Well, they tell you right there. The distance from the helicopter to the slow car.
But it says to that car is 100.
Yeah. They tell you right there.
Because like you see like the angle of depression of slow cars is like
That's the slower car, right? He only went 160, the fast.
yeah, but then the question is the angle of depression in the slow car is 50 degrees, right? But then at the end it says from the helicopter this is to that car is 100. So like
Yeah, they're still talking about the slow car. Good. Huh? Can you guys do it? And I'll, just so you know, the answer to A is 34.2 km. The answer to B is, oh, sorry. The answer to B is, oh, I don't have the answer to A. This is the answer to B. Ah, the answer to A is 38.7 km. That's the answer to B. Those are the answers to aim for.